Okay, so just 1 minute last class summary. We were looking into we were looking into SVM, right? Support vector machine. Okay, in the last class we are looking into support vector machine. So we have seen the theory part. Okay, now we will deep dive into the programming, and then we will be seeing today we will be seeing logistic regression and few of the statistics, remaining portion of the statistics we are going to see. And with that, I am going to give you a brief introduction about the assignment for linear regression and support vector machine. Okay, so let's start again. So support vector machine, just a quick revision. So we have seen how exactly a support vector machine is, which is nothing but a hyperplane we are designing in n-dimensional space, which will categorize all the data into different points, right? Into different classes. So our main optimization algorithm is to m equals to, this is the main optimization algorithm we were talking about. So what does that mean? It means nothing but the distance from each point support vectors. We are only considering the margin points, that is known as support vectors. The distance of all support vectors from the hyperplane should be as far as possible, right? So we are iteratively we are trying to find out the best value for all the coefficients, like beta 0, beta 1, beta 2, like that, so that the distance for each point, each support vector to the margin should be maximum, right? So if another question is, when the data is not linearly separable, how to solve such kind of situations? When the data is non-linearly separable, we can convert the non-linear separable data to linearly separable data by using kernel technique. So there are four kernel techniques available, like polynomial kernel, RBF kernel, sigmoid kernel, and one more kernel type. Okay, so when you are using scikit-learn library, when you are calling the kernel function, you can pass which kind, that we will see today. Okay, how to see the performance using different kernel techniques. Okay, this is the all theory behind. So this is the main equation cost function, which can be nothing but which can be written as this. Okay, the maximization of this algorithm or the minimization of this will give us the best value for betas, which will give us the best optimal hyperplane, which has the maximum margin. Okay, that we all have seen. The theory part is over, so let's deep dive into the programming. Okay, so now we are doing again, the procedure is pretty similar to other algorithm, like how we have done. So only difference is, instead of importing linear regression or logistic regression, here you are importing SVM module of sklearn. Okay, so first import all the libraries. Here we are importing numpy and matplot library because we are going to see some visualization. Then what we will do, your real task starts from here. So from sklearn we are importing, one second, from sklearn we are importing import data sets. So there are some built-in data set available in sklearn for practice. So we are taking one of such inbuilt data set present inside sklearn library, that is iris data set. Okay, so let me introduce you to the iris data set. Iris data set has 150 records. There are four different columns present. Okay, one is your sepal length, sepal width, petal length, and petal width. Okay, so there are four columns: sepal width, sepal length, petal length. Okay, and finally one target column, that is class. So based on these four columns, which category the iris plant will belong to, like iris setosa or iris, there are three classes you can see. So it is basically a three classification problem, right? It's not binary. There are three classes: iris setosa, versicolor, virginica. So there are the three target variables. Based on all these columns, we have to finally categorize one record to each any one of these classes. Okay, and there are how many such records? A total 150 records. This you can know by using, as we have used, right? DESCR method. Describe method will give you all the description, maximum, minimum, statistical summary of the data set you can get by using DESCR. Okay, now once we done with that, what we can do, so we will import the SVC from sklearn. we are importing the SVC module. SVC is nothing but support vector machine module we are importing from scikit-learn. Okay, this is done. Then as I told you, like, you have to create an object of that particular method. So a model is nothing but instance, you can say one instance of SVC method. So we are calling, once we imported, we are calling the SVC method here, and we are creating a instance of that class. Once it is done, then as I told you, we have to split the entire data set into training set and testing set. So we got our xtrain, xtest, ytrain, ytest. Okay, so how we are calling, we are by calling train test split. Again, it is a inbuilt method of sklearn, using which we are splitting the dataset into training and testing. And then finally, the procedure is exactly same for all algorithms. Okay, only what you need to understand, in real life scenario, applying machine learning techniques is very easy. Okay, where is the challenging part? Understanding where to use. Like I told you, few categories, like few points where you can use SVM. So where you can use, when you have high dimensional data, like where here, like we have only four columns, so it may not give me good result. But when it is very high dimensional data, let's say 50, 60, 70, and like so many high dimensional data, in that case if I apply SVM, that will give me good result. Okay, this is one of the category. So again, no worries. Finally, we are going to, in this machine learning class, we are going to read one method known as ensemble method. So ensemble method is a hybrid method where we will check which algorithm, particular algorithm is giving us a very good result. So seeing on the performance, we will implement the particular algorithm. Okay, at the end of machine learning class, we are going to see ensemble method technique. As of now, it's pretty simple. First, you have to import, then you have to create an instance, then you have to split the data. Step number 3. Step number 4 is called the fit method. Model.fit xtrain ytrain. So it will do nothing but create the model. So model training is done here. Okay, model training is done using xtrain ytrain. We trained our model. Our model is ready now. So let's now test our model. So what we will call the predict method. Okay, which will help us to test our performance. Okay, so finally, what we will do, we will call the predict method here. You can see predict model dot predict, and we are passing the x test value. So x test has all the columns except 20% of the data in x test except the target values. So predicted are nothing but very similar concept, just as what we have seen in linear regression, right? So predicted is nothing but the predicted outcome for x test values. Corresponding x test value y column is predicted by the model. Now we have the real value present in y test, right? Now what we are calling, we are calling the accuracy score method by passing the expected and predicted. Expected is nothing but original value, predicted is nothing but predicted value uh, by the model. So we got the score as 1, which is pretty good. So by seeing the score, we can see it is, one second, excuse me. Excuse me. Okay, so it is almost like 97.4% accuracy. Okay, so so what it is predicting? It is predicting the, if we give the sepal length, sepal width, new value for sepal length, petal width, the model is telling us, seeing the sepal length, petal length, it is telling us which class that particular iris plant will belong to. Okay, it is predicting a class for us. And if we want to see in real life, we have the original value where con we are like comparing the original value with the predicted outcome. Okay, this is pretty similar as we have done. So finally, what we have done, so there are different kinds of kernel techniques I have told you, right? Now that's we are so lucky that initially by default the kernel technique is, I think, RBF. If you don't pass anything, the by default method is RBF. When fitting the model, no, you should pass the parameter. Here we have not passed any parameters. I believe by default is SBF, RBF. But uh, let's say you got only 60% accuracy. Here we are so lucky that we got very good accuracy. But let's say your accuracy has not meet with your threshold, and you want to customize your algorithm. What you can do, you can try with some other kernel technique instead of RBF. You can try with some other kind of techniques. So there are so many techniques like Gaussian radial function, SVC, polynomial, third degree kernel. You can go through all this theory, what kind of kernel techniques you have. So the different kinds, as I told you, polynomial kernel, RBF, linear SVC. Okay, so many are there. So let's see by changing the kernel type whether we are getting any change in the performance. So what we are doing here, uh, we are doing everything, but when we are calling the SVC function, no, okay, when we are calling the SVC function, uh, SVC with linear example is nothing but the original one, whatever we have. Here we see here when we are calling the SVC, we are uh, when we are calling the fit method, we are passing some other like parameters also. Okay, in the first here, let me again repeat. See here, when we are calling the fit method, we have done nothing. All the default values we have taken, right? Here we have built the method, and then when we are calling the fit method, so in SVC, when we are calling SVC, we called nothing. I mean, we call only the default values of SVC. So SVC have three parameters that you need to understand. One is penalty. C is nothing but penalty. Gamma is one parameter, penalty is one parameter, and kernel type is third parameter. If you don't pass any parameter here, it means it will take all the default parameters, whatever is default parameter. But let's say you want to customize your algorithm. If let's say you have not got good performance and if you want to customize your algorithm, while you are calling SVC, you can change the parameter values and you can see whether it is impacting the performance or not. Okay, so that's what exactly we are doing here. What we are doing while calling SVC, we are passing kernel as RVC. Sorry, the default is linear kernel. So here we are passing a different kernel method, that is RBF, radial basis function, and the gamma value we are changing to some value, let's say 0.7. And then the C value, by default the C value is 1, so we are keeping this as the default value. Please google what are the default value for SVC. Okay, and if you want to change the default values, you can specify your own value here in this while calling the SVC. Okay, and then we are calling the fit method with all this thing. So RBF SVC is nothing but we are calling the SVC with all this. And now poly SVC we created again another thing, instance with all these values. Here the kernel is not RBF, here the kernel is polynomial, and the degree is 3. And C is C, means in the sense C is C, in the sense C has its own default value 1. I think the default is, I think, 1, and gamma is also default is 1, but the kernel type is here difference. So linear SVC again different, so C is C. So there is inbuilt function known as linear SVC. So here also in this way you can write, otherwise in this way also you can write kernel equals to linear SVC. Here instead of polynomial you can write linear SVC. Okay. So now with all these different values, what we will do is leave about this is nothing but simply plotting, but we will see the machine learning part. Okay, so with that what you can do is, okay, so with all this linear SVC and RBF SVC, it is trying to see what exactly what value we are getting. Like through visualization, we are checking which is giving us good result. Okay, which method, particular method is good, giving us good result. So this is again a different here. See, I don't want to confuse you guys. So see, don't confuse. Okay. So applying the same machine learning technique, you have so many different ways. Okay. We are applying machine learning techniques using scikit-learn, which is pretty useful and pretty very much important, but using another module known as numpy module. Using numpy also you can apply all these techniques. Okay, so here what we have done is, see here we have like one second. So we got our using fit model, we have trained our model, right? So RBF SBC is the model which got trained with all these parameter, RBF gamma and C. Poly SVC is the model which has got trained with all this parameter, and linear SVC is the model which got trained with all this parameter. Now it is the rest part, this is what we can. But how to check the performance? One thing is you can call the score method, right? Now you got your RBF, SBF, poly SBC and linear SBC, right? So here, how you are testing here, predicted equals to model dot predict x test. So here instead of model, you just replace the model name. What is the model name here? Model name is what you got, RBF SBC. Okay, so instead of only model, you can replace RBF SBC there. Okay, instead of model, just called here RBF, because the new trained model is RBF SVC, which is trained with customized parameter. Okay, so this I replace here. Similar with all. So now you can get the score and you can check whether the score is changing or not. Okay, you do the same thing with other. You have three things, right? RBF SVC, poly SVC. Poly SVC is nothing but the polynomial, for kernel type is polynomial. So here you replace poly SVC with the same and you can check the score, which I have not done. You can, maybe this you can take as an activity and you can check the score, and you can find out which of the particular kernel technique is giving you very good performance. Okay, and rest all whatever I have done here is nothing but visualization. So it is some advanced level of visualization. If you want to skip it, you can skip it. This is one way of checking. Okay, just try to find out the score and by that you can check. But if you want to find out the performance in visualization way, like I have done here, right? So finally I have created three graphs here with different values. Okay, so you can check, this is C, these are the points, these are the 150 sample records we have, right? So these are the nothing but the data set I have represented, and you can check there are three colors if you can see clearly. So one is green color, one is red color, and one is some other color. So there are three classes. Okay, for three different classes, three different colors. So you can see if you use polynomial kernel with degree 3, so your data is aggregating in this way. So it is nothing but to showcase you what is the difference when you only change the kernel parameter. Okay, nothing else. So this is the outcome. This is how it is separating different methods. Okay, different points. And if you use RVF kernel, you can see this is the this is how it is differentiating into three classes. And if you are using linear SVC, which we have used by default, it is separating in this way. Okay, and if we are using linear kernel, linear SVC is one and linear kernel is different category, so it is separating in this way. Okay, but it is again optional. Okay, all this visualization is like in real life you are not going to visualize all these things. What you are going to do, you are going to create a model using scikit-learn, and then you are going to fit the model with, when fitting the model, you can fit the model with different parameters changing, and then you try to find out the score for that particular model. Okay, and using the predict function and accuracy score method. Okay, this is nothing but from here, no, this is nothing but for better visualization to showcase you how exactly the, see, if I only change the kernel parameter, see how different it is. So it is like the separation is completely different. So that is what. So this is SVM. Okay, so it is pretty good classification techniques. um, I told you about linear regression, right? So linear regression we have seen. So let me
Shashmita,
yeah.
but like in linear regression, we
Uh-huh.
pass the number of like we differentiated the how much x train, how much x test, right? 40%, 50%. So in this one, we don't have to to that we don't have to pass that parameter or something?
See, there are two options, okay? So one option is if you want to, let's say, explicitly want to define. So let me, yeah, good question. So see, X trend, X test, Y trend, Y test. If you don't pass anything, it will do by default. But there is some default 80-20, or I don't exactly remember the default, but there is some default percentage. We are calling the method, right? Train test split method we are calling. So the train test split method will take the default if you don't pass any value, okay? But let's say you want to customize that. Let's say you want only 60 and 40%, or let's say 50 and 50%, or 30 or 70%. Any percentage, like if you want to customize it, you can pass the value how much percentage you want to segregate, okay? But if you don't pass anything also, it will do, I think the default is 80-20. In 80-20 ratio it will do, but I'm not confirm. You can check what is the, just type what is the default percentage of train test split, okay? So
Okay.
default percentage is nothing but I think 80-20, some percentage is fixed. With that it will differentiate, but it is up to
Okay.
you. It is also customizable, okay? So you, if
Okay.
you see, one more thing, this fit method has all this. You can check here, you can check if you see the output, no, what all the default value you can check. The what is the default value? Here we have done using the default value, right? SVC. So the default value is C. So many parameters are involved, okay? C equals to 1, cache size equals to 200. This is like memory size, leave it. Class weight none, coefficient 0, degree 3, gamma. So degree is one of the parameter you can pass, otherwise you can keep it constant. What you need to pass, this is important, okay? So when you go to real life, when you go to, when you're handling some of the company project, and your let's say your manager told this model is not that much good because it is giving only 60% accuracy, can you please customize the algorithm? If that is the question, what you need to do there, in that case you have to change all this parameter, and again you can check the score whether it is giving you good result or not. What you can change, one parameter you can change is gamma value. Say here by default the gamma value is 0. If you remember in the when we are calling the RBF, we have changed the gamma value to 0.7. Similarly, you can write a for loop for gamma value 0 to 0.1, okay? And you can check like in iteratively you can check which gamma value is giving you good result. That is one way. Another way is you can check C is nothing but penalty, okay? The error, like the constant factor, this also you can check, change. Third is kernel. Here another method is kernel, okay? Kernel also you can check RBF, or what kind of kernel you want, you can change here. Maximum iteration is -1, so how many iteration you want, so that also you can decide. 10,000, 1 lakh, 2 lakh. So how many iteration you want, that also you can check, okay? So these are the default parameters which you can change. So one is C, one is degree, gamma value, kernel, maximum iteration. Change all these things and see which is giving you good result, okay? Based on that you can apply whichever is giving you
Okay.
good result, that you can apply in the final model, okay?
Yes. Okay.
Yeah, so there is one assignment for you. 1 second. So, okay, so this is a very good assignment, okay, and this is like a real life mini project, okay? It's like an it's an assignment, but it's like a mini project. So please do it. Just what you will do is linear regression. You first see the IPY file, whatever I have shared. So based on that, exactly same to same, you have to do the coding here. The solutions are also available. Don't go for solution. Try to do it by your own, okay? So this, the problem statement is there is a data set, e-commerce company, okay, New York City data set. The, what is it? The sales of clothing, okay, the sales of clothing data set. So customers come into the store, have sessions meeting with the personal stylist. They then they can go home and order either on a mobile app or website for the clothes they want, okay? The company is trying to decide whether to focus their effort on their mobile app experience on the or their website, okay? So the company is trying to decide whether to focus their effects on their mobile app is giving good result, or they should focus on the website part. Okay, so they have hired you to contract to help them to figure it out. See why I have explained so much, because in interview, okay, in data science interview, nobody is going to ask you problem like mathematical derivation. Nobody is going to ask you. Okay, they will ask you exactly similar to this. They will give you a problem statement, like the problem has been described here, right? Exactly similar. I mean 80% chances that definitely they will ask you one question in this area. Okay, so they will ask you exactly this thing, the company is there and this thing is there and this, can you give me a solution? They will ask you like this, can you give me a solution for that? Okay, so first thing is you have to decide based on the problem statement which model will fit, whether it is a regression problem. No, first you have to find out whether it is a supervised problem or unsupervised problem. Then you have to find out in supervised, if it is a supervised, then whether it is a regression problem or classification problem. If it is regression, then you can apply any of the technique. If it is classification, which technique you need to apply. If you are clear in that, you can crack any interview. That is more than enough. Okay, so if you are applying SVM, why? If you are applying any other technique, why? That you need to clear. And in SVM, what are the parameters when you are calling SVC function? This much only you have to remember. Don't see so many students got very really afraid of machine learning because all this mathematics. But in real life, nobody is going to ask you the derivation part. No, at max, in if you are attending very good company interview, maybe they can ask you the cost function, which I already mentioned. Minimum, I have written, I told you, right? Maybe hardly they will ask that, but most of them, they will not even ask that, because the mathematical formula we are not going to remember. And if any case it is required, we can google it and we can find it out. What is important is whether we have understood the concepts or not. Okay, this is how you will get problem in real life in interviews. So now your approach, how to do that, you can go through the assignment. This is the problem statement. So the outputs are given. Okay, so this should be the output of the uh, data frame once you load it. So here the question, check the see read the e-commerce customer CSV file as a data frame called customers. The question is there, then your code should be here. Okay, now the question is there, your code should be here, and you know the output, you know the question. Now you have to write the solution for that. Okay, in this way you go. It is a complete, see all this visualization coding also you have to write. This is nothing new. Okay, same with that whatever I told you, the copy paste of the same, but the data set is different here. Okay, now see here, training and testing. Now that we explored it, set x variable equal to numerical feature of the customers and a variable y equals to yearly amount spent column. Okay, so similarly you can go through it. The solutions are also available. This is the solution. This is the solution for linear regression. So I will dump both. You can if you're stuck somewhere, you can see the solution. Okay, so now we have another kind of regression, that is logistic regression. We'll see it. So logistic regression is again the same. We are going to work with logistic regression. The theory is not here. So let me tell you what exactly logistic regression is. Logistic regression, I don't want to waste so much time because we have so many things to cover. What I will do is, it is pretty simple. The theory part is pretty simple. We are applying a logistic function here. Okay, so I will tell you the theory here. Just go through the class recording which I have uploaded in Google Drive. Okay, where I explained, I think 15 minutes only on logistic regression. You can go through that. I just want to save some time. Okay, so logistic regression is nothing but we are using a function here, logit function. Okay, what exactly a logit function? Logit function is nothing but this formula. Okay, f of x equals to 1 by 1 plus e to the power of minus t. Okay, here it is not x, it is t. In second. Okay, so here it is nothing but t. Okay, so this is known as the logit function. Okay, it is not a straight line. Okay, like we have seen in linear regression, like right, it is always a straight line. So logistic regression is not always a straight line. And when you can use logistic regression, that is again a question mark. When exactly you can use logistic regression? So logistic regression you can use when you want to apply classification, when you want to use regression for classification. Okay, so logistic regression, what it is doing is using this function. Okay, using this logic function, it will convert your entire data set into 0 to 1 range. Okay, it will convert all your entire data set into 0 to 1 range. Why we are using this function? The question is, why exactly we are using this logic function? So let's say your data set is let's say it's starting all the numeric values, let's say starting from minus 1000 to, let's say it is starting, let's say house price, we have seen the house price, right, in linear. So let's say the price column, right, the price, let's say starting from minus or maybe plus $1000 to, let's say some $6000 it is ranging. Okay, so if we apply this logic function, right, the entire data set will come into this range. So here what we will do, 1 by 1 plus e to the power minus t. T is nothing but each value, 1000, 1001, 1002, 1003 till 6000. Okay, if you apply this function to each of this item of the data set, the entire range will be in 0 to 1 range. Okay, so now what is our price? Our price column are values in between 0 to 1 range. Now how we can use this this regression model as a classification model? Okay, so regression is like predicting the house price, it is a continuous task. But classification is nothing but it is not a continuous task. You're not exactly going to predict any continuous value, rather you are predicting what category you have fixed color fixed values for target, 0 1 2 for 3. All the values can be 0 or 1 or 2 for target, right? But for regression the target value will vary. It is not only the 0 1 2, it may be house price, it will vary 100 200 300 $5000, it may be $1 million, any value, right? But if you want to apply, let's say the housing data set, how I can apply using to classification, using this logistic regression. Okay, now what I will do, 0 to 1 I got. Now what I will do, I will apply one inbuilt function, I will design a function, and I will tell all the house prices. Okay, let's say 0 to 1 I want to segregate into two classes. Okay, take the same example here, SVM. What we are doing here in SVM, Sepal iris data plant, right? So we have three classes here, right? So what we will do, we converted all the data to 0 to 1 value. Now what we will do, the values which are present in between 0 to let's say 0 to 0.4, all that belongs to class 0. The data which is present in between 0.4 to 0.8, all that belongs to class 1. And the data which are belong from 0.8 to 1, all those belongs to class 3. So we will set a parameter here, we will set a threshold, whichever is coming in that threshold we will convert all those points to one class. So manually what we are doing is, all this 0 to 1 continuous value, we are separating this continuous value into some classes. So maybe we can differentiate it into two classes, 0 1 and 2 class. Okay, so all those value were coming under 0 to 0.4 will fall in 0 class, 0.4 to 0.8 1 class, and 0.8 to 1 will fall under 2 class. Okay, if you want to know more detail, please go through the class recordings. Okay, there I have explained very well the theory part, you can go through it. But now I will show you the coding part, how to do that with a different data set. Okay, so the data set is again advertising data set. So what are the data set, how the data set is looking like? So the advertising data set indicating whether or not a particular internet user clicked on an advertisement on a company website. Okay, so this is nothing but the project solution I am explaining you, the logistic regression project solution. So what is the main goal? The main goal is, we need to predict whether a particular user, if we are broadcasting an advertisement to the user, how the user is reacting, whether he is clicking on the advertisement or he is leaving it, he is not clicking the advertisement. That is the problem statement. Okay, and what are the features available? All these features: daily time spent, age, area income, daily internet usage, topic line, city, mail, country, timestamp, clicked on ad. Okay, so this is the target variable, clicked on ad. Okay, 0 means yes, and yes, he 0 means no, he has not clicked on. 1 means yes, he has clicked on. This is the data set. Okay, so now this advertisement.csv I'll be dumping. You can export it and create a data frame. Okay, so now using the info method you can get all the details, like how exactly your data frame is. So that is, there are 1000 entries and total 10 columns. Okay, and these are the columns with all this detail. Fine. Now what you can do, you can do some exploratory data analysis, which is like your optional choice, but directly we will jump into the machine learning part. Okay, so machine learning part, what we can do, how we can apply this all things using machine learning. Again, we will import the train test split. Okay, and x is nothing but except the last column, all other column, basically we are taking only the numeric data value columns. Okay, because regression only works with numeric data, it will fail for categorical data. If you have some categorical data, you have to convert it to numerical form. Okay, so now we have taken all this data, y is nothing but the last column value, we have splitted it. So your doubt, so here we have not based on the default value, we want to customize it. That's why I am specifying the test size here. So I have specified, let's say 33% should be in the testing data, rest all 77% will be on training data. So that's the reason I am passing this parameter, test size. Okay, and random state is nothing but to see the same output as of mine. Okay, so then what we can do, okay, again we can import the logistic regression module. The procedure is very simple. If you understand once, you can apply all the algorithm of sklearn. Okay, you have to import it. The fourth step is create an instance. Log model is nothing but an instance by calling the logistic regression function. Fifth step is call the fit method and fit the x train and y train, right? And the last step is predict, so we are calling the predict on x test. And finally what we are going to do here, there is something else. Okay, as of now we are using only accuracy score, which is giving us a score, but now we are using another method known as classification report. So it is end-to-end report, you'll be getting everything, you'll be getting like precision, recall, f1 score and support. Okay, so your assignment, I will explain, but first you need to explore it. Write it down. Your assignment is what is precision, what is recall. It is again a text mining concept. Okay, but just write down what is precision, what is recall. Okay, try to find out, try to google, you will get lots of answer, just go through it. Any doubt you can ask me, I'll explain in the next class. Okay, so what is precision and what is recall, it is important. So that's the f1 score is nothing but the score we have seen, but you have to find out what is precision and what is recall. Okay, so again this, by seeing this you can find out how accurate your model is. The procedure is very simple. Instead of linear regression, you have to only call logistic regression model. Okay, so now one more thing I just want to let you know, that is uh, statistics normal distribution model. So, or maybe we can yeah, so one more thing I will one statistical concept I will let you know, that is covariance and correlation. Please write it down. If you want to know more detail, like more mathematical part of covariance and correlation, I will give you a brief summary. Here we are covering everything, but if you want to explore more, you can also explore what is recall, what is precision, what is covariance, and what is correlation. Okay, but in short, if I tell, covariance measures how two variable are vary in from their mean. Okay, standard deviation, covariance, correlation, everything is nothing but we are simply checking how the data set is distributed, how it is behaving towards its mean, how tandem from their means. Okay, how two variables vary. So the question is, in your company, if someone is asking you, can you tell me how these two variables are related? Or in interview, if someone is asking how you can get to know how two variables are related to each other, then you can say we can find out the correlation between those two variables. Again, correlation and covariance is direct inbuilt method available inside sklearn. You can directly call those method and use it. But here in this in this slide, instead of calling directly the methods, we are trying to find out what exactly the covariance and correlation is, and we are trying to implement our own. We are going to try the mathematical formula, we are going to code it instead of calling simply the inbuilt functions. Okay, but if you don't want to call and you want to call the inbuilt function, that is also fine. Okay, so what exactly we are doing, see here we are defining the mean function. Okay, so which is doing nothing but d mean. What do you mean by d mean? Difference from mean. So we are calculating a difference from mean function. Okay, difference from mean function is doing nothing but it is returning the difference from each point to the mean. Okay, x mean is nothing but the mean of that point. Okay, so x mean is nothing but the mean of each point, the mean of this entire data set x. Okay, now what it is returning, the difference mean function is returning the difference of each point. Xi is nothing but each point of the data set to mean. Okay, for each xi in x, we are calculating what is the difference from that point to the mean, and we are returning. Fine. Then what exactly a covariance? Covariance is nothing but, okay, difference of each mean, dot product of difference of each point to the mean. Okay, and similarly difference of y is nothing but again the difference of each y from the target variable from the mean divided by n minus 1. What is n? N is nothing but number of sample. That's why I'm telling, if you want to see the exact mathematical formula, you can Google it. Okay, what is the formula for covariance? So we are doing nothing but we are trying to build a covariance method, which is nothing but dot product of difference between each point to mean divided by number of sample minus 1. Okay, that is covariance. So now what we are doing, we are creating some random data set using random normal. Random normal function is it will create 10,000 points in between 3 and 1 range. Okay, in between 3.0 to 1.0, we are creating 1000 data points. Okay, which is nothing but page sets. This is one variable. Let's say this is x variable. Okay, now what is y variable here? Y variable is page amount, purchase amount, which is nothing but 50 to 10. In between 50 to 10 range, we are creating 1000 data points. Okay, now we are doing the scatter plot as well as if we want to find out the covariance, this is our x. Okay, this is our x and this is our y. Okay, so we are calling the covariance method here. So here it will go this function. Okay, it will go this function. So what it is doing, n is nothing but the length of x. Length of x is length of page sets. Okay, and then it will find out d mean. It will call the d mean. So again it will go here. Okay, from here it will go to this function, calculate the mean from each point to mean, find out the x mean and find out the difference. Finally find out the y mean, find out the difference, and then do a dot product of those means divided by n minus 1. That will give you the covariance. Okay, so once you got the covariance, you can check the covariance is minus 5.02. So it is like negatively impacted. It is not so positive. It is negatively impacted. So one is increasing means other will be decreasing. Okay. Now we will make so there is no, again it is not good result. So if it is minus 0.9, it means very negatively, or if it is only one positive means very highly covariated, but it is in between. So you can see from the scatter plot, there is, you can see directly there is no relationship exist. So mostly it is you can say not linear, no, not any, not dependent, or maybe not very much related with each other, those two variables, right? Similarly, if you want to find out, this is again the same example, correlation. So what exactly correlation is? Correlation is nothing but covariance is sensitive to the units used in the variables, which makes it difficult to intercept. Okay, so interpret. So correlation normalize everything by their standard deviations, giving you an easier to understand value that ranges from -1 to +1. Okay, so covariance, it is very difficult. By seeing the covariance value, it is very difficult to know the relationship. But what is correlation? Correlation is nothing but very much similar to covariance, but it is normalizing the result. Okay, so the correlation result will always vary from -1 to 1. If you are getting -1 means very inversely impacted. Let's say the correlation value for two variable is -1, means what you are intercepting, if one is increasing, other is decreasing. If it is 1, then it is perfectly positive. Okay, that's what you are inferring from that. So finally, how you can find out correlation? So one is even yeah, one is like x dot standard. You have to find out the standard deviation of both the variable, and now whatever the covariance you got, okay, just divide the covariance with the standard deviation. Okay, and that will give you the correlation. Correlation is nothing but covariance divided by standard deviation. Okay, that will give you correlation. So it will again vary from -1 to +1. Okay, so uh, that is what. So this is a correlation and covariance. Again, it is pretty important, very much handful when you are dealing with, let's say you want to know what, how exactly two variables are impacting each other, you can find out the correlation. So don't go for covariance, directly you can apply correlation. Okay, so today what we have studied, we have seen logistic regression, we have seen support vector machine, we have seen covariance and correlation, and also we have seen the project for linear regression. Okay, so your assignment for today is just try to finish up the linear regression project. With that, you have to find out what is precision, what is recall, and what is correlation and covariance if you want to know more mathematical part. Okay, but no worries if you don't want to write all this algorithm, I mean all this coding, it is fine, perfectly fine. sklearn has covariance and correlation. Just call the correlation function, passing the xy parameter, it will give you the correlation. Directly you can use it. Okay, it is just to make you understand. Okay guys, any doubt for today's class?
No.
Okay, so you can go through it. Any doubt you can ask me in the next class. Okay, so from next class onwards we'll be seeing 5 to 10 minutes again, few statistics like normal distribution and uniform distribution. With that, we are going to start another new machine learning classification technique, that is decision tree. Okay, if you want to pre-prepare for the class, please pre-prepare. So decision tree, I will be uploading the slides also, but don't see my slides, you just try to google and try to find out something from internet about decision tree. It's better if you can clear the theoretical part, because coding part we are seeing here, right? I will like repeat everything, but pre-prepare for the class so that you can ask any doubts if you have. Next class we are going to see decision tree, okay, which is very important algorithm again. Fine
Okay.
guys, yeah.
Thank you.
Yeah, thank you so much. Yeah.